Hello students, welcome to A-Star Tuition channel. Today we are going to learn about the lecture on indices along with the example as well as the graph of exponent. Indices is one of the most important chapters in algebra, so please make sure that you have the good concept and understanding on this. Okay. We're going to start with the rules of indices here. The first one is a to the power of x times a to the power of y is equal to a to the power of x positive y. Okay, here is the example to verify this. 2 to the power of 3 times 2 to the power of 2 is equal to 2 to the power of 3 positive 2 according to this rule. 2 cubed is equal to 8. While 2 squared is equal to 4, and we have 2 to the power of 5 on the right hand side. 8 times 4 is equal to 32, 2 to the power of 5 is also equal to 32. Therefore, this first rule has been verified. The second rule, it's quite similar to the first rule, okay, which is the division of two terms having same base and different power. A power x divided by a to the power of y is equal to a to the power of x negative y. Example, 2 cubed divided by 2 square is equal to 2 power 3 negative 2. 2 cubed here is equal to 8 divided by 4, while on the right hand side we have 2 to the power of 1. 8 divided by 4 is equal to 2, which is equal to these 2. So it has been verified. Okay. The next one, rule number 3. A to the power of x to the power again of y is equal to a power x times y. Example, 2 squared to the power of 3 is equal to 2 power 2 times 3 here. On the left hand side we have 4 cubed, okay, because 2 squared is equal to 4, while on the right hand side we have 2 power 6. 4 cubed is equal to 64 and 2 power 6 is also equal to 64. Therefore, rule number 3 has been verified. Moving forward, rule number 4. This is the product of two terms having different base while having the same power. A power x times b power x is equal to a times b to the power of x. Example, 2 power 2 multiplied by 3 power 2, okay, which is equal to 2 times 3 square here. 2 square is equal to 4 and 3 square is equal to 9. On the right hand side we have 6 square. 4 times 9 is equal to 36 and 6 square is equal to 36. Therefore, rule number 4 has been verified. Going forward, number 5. A power x divided by b power x is equal to a over b to the power of x. Example, 4 square divided by 2 square is equal to 4 over 2 square. 4 square is equal to 16, while 2 square is equal to 4. On the right hand side we have 4 divided by 2, which is a 2 square here. 16 divided by 4 is a 4, and 2 square is also equal to 4. Therefore, rule number 5 has been verified. Okay. Now, the last two rules here won't have the example. So students are just required to take it for granted. Number 6, this is the rule about negative power. A to the power of negative x is equal to the reciprocal of a to the power of x. Okay, this is the technique to switch from negative power into positive power. And the last one, any number to the power of 0 is equal to 1. Okay, except 0 to the power of 0. So I do hope that you gain the good understanding on the basic rules before you apply them into the problem solving. Okay, the next step of our discussion is on the graph of exponent. Okay, next we're going to discuss on the graph of exponent. And the general equation of our discussion here is y equal to a to the power of x. We will split the following discussion into the case when a is bigger than 1 as well as a in between 0 and 1. Exponent itself is a rapidly increasing function. And the general graph of this looks like this. Okay, this is called the y-intercept. Y-intercept is defined as the y value when x is equal to 0. So the coordinate of this y-intercept is 0, 1. Okay, this one comes from a to the power of 0 from the previous rule. Okay, we can actually verify such thing by looking at the endpoints. When x is approaching to negative big, let's see what's going on. Okay, you can pick a random number such as a equal to 2. So this graph will be 2 power negative big. We know that 2 power negative big could be written as 1 over 2 power big, which is equal to reciprocal of a big number, and this is approaching to 0, but still positive number. Okay, this is being shown here. And for the case of x approaching to a big number, this y is equal to 2 power big, which is equal to big number, and is approaching to positive infinity, which is shown by the right endpoint here. Okay, for the case of a in between 0 and 1, we can go for a equal to 1/2, for instance. So this, the y we are dealing with is equal to half power x, which can also be written as 2 power negative 1x, which is equal to 2 power negative x. Now, there is a resemblance between this equation and the previous equation, 2 to the power of x here. 2 power negative x is essentially equal to the graph of 2 power negative x is essentially the reflection of the graph of 2 power x by the y-axis. And therefore the graph of 2 power negative x would look like this. This is the y-intercept and it remains unchanged, which is 0, 1. So as you can see that this graph is approaching to 0 when x is approaching to a big number here. Okay, it's basically the reverse of this graph by the y-axis. Moving forward, we will also discuss two additional graphs of y equal to negative a power x for the case of a greater than 1 as well as a in between 0 and 1. The negative preceding the function here will reverse the original function or reflect the original function by the x-axis. Okay, it's basically the reflection of this one by the x-axis, and therefore the graph of such equation would look like this. Now it's a rapidly decreasing function, and the y-intercept is 0, a power 0 is 1, but there is a negative preceding it, so it's negative 1 here. Okay. While for the case of a between 0 and 1, we just need to do reflection of the following graph by the x-axis, and therefore it would behave in such a way, and this coordinate is also equal to 0, negative 1. So here are the 4 graphs of the exponential that students need to grasp before they actually move on to the more advanced chapter on the logarithm. Okay, thank you for watching this video. Please comment, like, and subscribe this channel. See you again in the next video.